Hi students, welcome all for our third semester classes. Let's start our classes from thermodynamics. First of all, we are going to study about general introduction of thermodynamics. Thermodynamics, the word implies flow of heat, which is derived from Greek word thermos means heat, dynamics means flow. So, thermodynamics means flow of heat. It deals with energy changes accompanying all types of physical and chemical process. For example, burning of fuel to produce heat energy, flow of electrons through circuit to produce electrical energy. These are all the examples for physical and chemical process of thermodynamics. Next, we are going to see about some basic terms of thermodynamics. First one is system, second one is surroundings. This figure shows the system and surroundings. Let us consider the universe. The universe is divided into two parts, one system and its surroundings. The system is the part of universe which is under thermodynamics consideration. It is separated from the rest of the universe by real or imaginary boundaries. So, the system is defined as any specified portion of matter under study which is separated from the rest of the universe with a bounding surface. Matter means here the matter means to anything that occupies space and has mass is known by the matter. The three states of matter is solid, liquid and gas. So, a system may be defined as any specified portion of matter under study which is separated from the rest of the universe with a bounding surface. So, next is the surrounding. Surroundings is the rest of the universe which might be in a position to exchange energy and matter with the system is called the surroundings. So, this is the system and surroundings. Next, we are going to study up the types of system. Isolated system, closed system, open system, macroscopic system, homogeneous system, heterogeneous systems. These are all the types of system. This figure shows the isolated system, closed system and also open system. First, we are going to study about the isolated system. A system which can exchange neither energy nor matter with its surroundings is called an isolated system. So, let us consider the vessel containing matter such as liquid. It is covered, that means closed. This vessel is closed and also insulated. That means like a flask. So, here the system vessel is in this system the vessel is closed. So, no matter means liquid, no matter can leave or enter the vessel. So, further if the vessel is also insulated, so it is neither in a position to lose heat to nor gain heat from the surroundings. So, in short, the system is not in a position to exchange energy or matter with the surrounding. This is thus an isolated system. Second was the closed system. Closed system, a system which can exchange energy but not matter with its surrounding is called a closed system. In this above example, if the vessel is closed but not insulated as shown in figure 2, it will be able to exchange energy but not matter with the surroundings. So, this is called as the closed system. We can take another example. For Consider a gaseous mixture consisting of oxygen and hydrogen in the ratio of 1:2 by volume enclosed in the cylinder is shown in figure 3. The cylinder is closed by the frictionless piston. This reaction proceeds when initiated, evolving the considerable amount of heat in accordance with this reaction. Hydrogen plus oxygen gives the H2O. Here some energy, that means heat, is evolved to transferred from the system to the surroundings. So here the temperature of the system remains constant. At the same time, the reaction is accompanied by the decrease in the volume. The piston moves downward so that the pressure remains constant. In this way, some work is done by the surroundings on the system. So thus again, transfer of some energy in the form of mechanical work has taken place from the surroundings to the system. But this is since the cylinder has remained closed throughout. So there has been no transfer of matter from the system to the surroundings. Okay, this is called as the closed system. Simply says a system which can exchange energy but not matter with its surroundings is called as a closed system. Next one is the open system. A system which can exchange matter as well as energy with its surroundings is said to be an open system. Consider the evaporation of water placed in an open beaker. The water vapor, that means here the water vapor is the matter, will escape into the surroundings, while the heat energy required for this vaporization will be absorbed from the surroundings. So this is the case of open system. So let us consider the another examples. Reaction between zinc granules and dilute hydrochloric acid taking place in open beaker. Here the hydrogen evolved will pass out from the system to the surroundings. At the same time, the heat evolved in the reaction will also be transferred to the surroundings by radiation. So thus there has been exchange of matter as well as energy from the system to the surroundings. This is called as the open system. Next one is macroscopic system. Macroscopic means in a large scale. Here a system is said to be macroscopic when it consists of a large number of molecules, atoms or ions. Is called as the macroscopic system. Next one is this homogeneous system. A system is said to be homogeneous when it is completely uniform throughout. For example, a pure solid or a liquid or a solution. These are all the examples for the homogeneous system. But the homogeneous system consists of only one phase. So this is called as the homogeneous system. Next one is this heterogeneous system. A system is said to be heterogeneous when it is not uniform throughout. For example, a solid in contact with a liquid and also two or more immiscible liquids. So these are all the examples for the heterogeneous system. So these are the types of system: open system, closed system, isolated system, macroscopic system, homogeneous and heterogeneous systems. Next one is the state of a system. State of a system means when macroscopic properties of a system have definite values, the system is said to be in definite state. Macroscopic properties means pressure, temperature, volume, mass. These macroscopic properties of a system have definite values. The system is said to be in definite state. So whenever there is a change in any one of these macroscopic properties, the system is said to change into different state. Thus, the system of a system is fixed by its macroscopic properties. This is the state of a system. Next one is the state variables. State variables means since the state of a system changes with the change in any of the macroscopic properties, these properties are called state variables. These are the state variables. So let us consider the pressure, temperature, volume. These are all these state variables. when a system changes from one state to another state, that means initial state to final state, there is invariably change in one or more of the macroscopic properties. Okay. Here pressure, temperature, volume, mass and composition are the most important state variables. Hmm. These state variables classify into two types. One is independent variables, second one is dependent variable. For example, if the ideal gas, let us consider the ideal gas and 1 mole of the gas is under examination, it obeys the equation PV equal to RT. Here R is the gas constant. If the only two of the three variables, that is pressure, volume and temperature, here two of the three variables are known, the third can easily be calculated. The two variables generally specified are temperature and pressure. These are called independent variables. The third variable, generally volume, is said to be a dependent variable as its value depends upon the values of pressure and temperature. So the volume is considered to be the dependent variable. Thus, the thermodynamic state of a system consisting of a single gaseous substance may be completely defined by specifying any two of the three variables via temperature, pressure and volume. So, this pressure, temperature, volume, pressure and temperature is the independent variable, volume is the dependent variable. So, in this class, we are all study about the general introduction of thermodynamics and basic terms of thermodynamics like system and surroundings, and also types of system, that is isolated system, closed system, open system, macroscopic system, homogeneous and heterogeneous system. Next is the state of a system and also state variables. Okay students, we will continue the rest in the next class. Thank you.